And we are live. Okay, hey folks, Phil Zito here, and welcome to episode 24 of the Smart Buildings Academy TV series. And in this episode, we're going to continue along with network basics, and we are going to talk through IP addresses, TCP/IP networking. We're going to talk about routing and switching. We're going to talk about all sorts of aspects. So let's go over to the whiteboard. Let's talk through these concepts, and then we'll move back here to take any questions. As we move through this video, definitely go and ask whatever questions you have, and we will go and take a look at those. All right. So here we go. So the first thing we got to do is we've got to go and once again list out our network topology that we were using in our previous episode. So it looks something like this. We had a switch here, we had a switch here, we had a router here. Our switch was connected via a trunk link to the router, and the router was connected to another trunk link here. Okay, so at this point we have a local area network here, a local area network here, and then this is being combined with the router, which is enabling us to have two different networks, two different logical and physical networks connecting to each other. Okay, so this switch, which we're going to call switch 1, and this switch, which we're going to call switch 2, is going and it's showing us kind of, here's switch 1, here's switch 2, and switch 1 is connecting to a host via an access link, right? And this host is going to have an IP address. Now, here's the first thing we got to talk through. So we had MAC addresses in the previous episode, Ethernet MAC addresses, and those were the physical addresses of the network interface cards. Now, a IP address is a logical address, and it allows the traffic from a device, from a host device, to travel to other host devices, either across the internet or just across a regular local area network. Now, with an IP address, we have what are known as 4 octets, right? And an octet is a series of 8 bits that, when activated, equal a number. So if you see 192.168.1.100 is an IP address, and if we do a /24, this dictates out which portion of this address belongs to the network and which portion of it can belong to hosts. So each host can have an address in a range, in an IP address range. But with /24, since each one of these octets right here is 8 bits, basically you have, 128, 64, 32, 16, 8, 4, 2, 1, and when these are activated, right, they add up and they equal the address. That's how that address is created. Well, the 24, so these 8 bits here, the 8 bits here, and the 8 bits here in this octet, right, those belong to the network. So 192.168.1 right here, this is the network. And then there's 8 more bits. So if we know that there's 32 bits in an address, 32 minus 24, there's 8 bits here that belong to the net or to the hosts. So I can go and 2 to the power of 8 is 256. So I have 256 potential host addresses. That's not exactly the case because right here with a IP network, I have to have a default gateway address, which is typically at the router, and I have to have a broadcast address. That's where all broadcasts get sent. And so that is 2 addresses. The broadcast address is always the last address of the range, of the host range, which in this case will be 255. And the default gateway can be any, although it's usually the first. So that would be .1. So what happens is, if this network device wants to communicate to another network device that's over here, right? Here's the host. But this one is 192.168.2.100/24. This right here is a separate network, 192.168.2. Now what happens if we remember the address resolution protocol table, the ARP table that exists in the switch that says the Ethernet address is equal to this IP address. There is no entry in the ARP table for that subnet because the Ethernet and the IP addresses exist only in that subnet's context. So even if, and this is going to kind of blow your mind, even if this 192.168.2.100 was over on this switch, this device still would not be able to see them because they're separate ARP tables. It would have to go to the router and get sent, right? It would get sent to the default gateway, and the router itself at the default gateway would say, hey, this network is here, and it would send it back. That's basically how it all works. Now, what's going on here is when this device wants to communicate over here, the Ethernet frame is created, as we discussed in the last episode, so I'm not going to go through Ethernet frames. But that Ethernet frame inside it has the IP packet. Remember, there's frames, packets, and segments. Ethernet is frames, IP is packets, segments are TCP UDP. So at layer 3, we've peeled off the Ethernet frame, and we've determined what IP address this message is trying to go to. And that all happens at the switch. The switch will peel off the frame. It'll see that, okay, it's trying to go to this IP address. So it's trying to go to whatever address it's trying to go to. You know, in this case, 192.168.2.100. And it will say, okay, that's not in this subnet context, so I'm going to send it to the default gateway, which is .1. So it's 192.168.1.1. That's the default gateway address. And once that happens, it will then put the Ethernet frame back encapsulating that IP packet, and the source will be here, and the destination will be the frame address for the router. Okay? So then, when it gets to the router peels that frame off again, and that frame now goes and actually exposes the IP address. Now, the router has a route in its routing table, and that route will say, for the 192.168.2.x network subnet, you need to go out this port right here, right? This port. And it'll say, okay, so you go out serial port 1-1. And then that traffic gets re-encapsulated as an Ethernet frame, and it has the source and destination address, so the source being this router, and the destination address being here, right? Because it'll get, the default gateway will get sent, and that actually happens typically at the switch, that encapsulation. Now, from an IT and BAS perspective, what we need to understand, we first need to understand subnets. We need to understand how do they work? Like, what does the /24 mean? What does that mean to us as far as how many host addresses are available? We need to understand about routing, because when we go to set up a BAS device, right? Let me clear this off real quick. I got a lot of noise on this board, so I'm going to clear it off, and we're going to kind of do this. So this host device, didn't mean to erase that. Let's say that this is a supervisory device. And right, it's got its BACnet MSTP devices on the trunk. And let's say it's 192.168.1.100. And let's say this right here is also a supervisory device. And it is 192.168.2.100. And it has a bunch of BACnet devices on it. Then what we need to know is we need to know what subnets these are, because we would go and create our BBMDs. Now, I'm not going to dive into BBMDs because we've discussed BACnet in detail in previous episodes, and we're going to be discussing it in further detail in upcoming episodes. But what I want you to understand is that by knowing the subnet, then at the BBMD, that's hard to say fast, you can enter into your BDT entries, you can enter the different subnets that need to have communication traffic flow through them. So if we didn't understand this, then we wouldn't know. Now also what we need to know is, like, if an IT person gives us, we tell them, hey, we need 10 addresses, and they give us 192.168.1-X, and they say, so 1-0, sorry. And they say for 10 addresses, they would give us a 16. So 16 would be what? It's 2 to the 4, so it'd be 28, /28. They give us a /28 address, and they say, this is going to give you the range you need. So what that would mean now, /28, 32 minus 28, right? That's 4. 2 to the power of 4 is 16. We're figuring out the host addresses for those of you who are wondering. So we have that. We have .0 /28. This gives us 16. So our range is going to be 1, 2, 16. I may have done that math wrong. It may be 1 to 15. But, and then this is going to be your broadcast address, and then whatever address you pick for your default gateway, which then would leave you 14 addresses left over that you could go and apply to hosts. I'm going to step over to the computer just a second to check on the questions because I know I've been talking for a little bit. So I'm going to check that real quick. Let's take a look. Does each port have a list or table of addresses? No. So it's not the port that has the list. It's the switch that has the address resolution protocol list. Okay. All right. So not seeing any other questions, we're going to step back. Okay. So right here, we've done some basic subnetting, right? We've subnetted out this network. We know our start and ending addresses. We know how many host devices we have. And then we can take those host device addresses and we can give them to our devices on that subnet. Now, at the router, we have to make sure that there's a route that exists between any BAS devices that we need to go and communicate with. Now, that's all well and good if we have isolated local area networks. But what if we have a VLAN, a virtual local area network, and we have a host device coming off of that that's on that .2 subnet, so 192.168.2.10. This can happen, and this throws a lot of people for a loop, is on a managed switch, you can have multiple subnets on a managed switch through VLANs. So my VLAN here, this is going to be VLAN 2, and then there's VLAN 1. VLAN 1 is this 192.168.1 subnet. VLAN 2 is 192.168.2 subnet. This is how IT will do a lot of things because you're not going to get all of your devices and drops on their switch, especially if you're using a ring or a bus IP architecture. Then you're typically going to have 1 to 2 ports on their switch, and the rest of the ports on their switch are actually going to be other VLANs, typically for their business systems or other building systems. So it's important that you understand how VLANs work. But all in all, understanding basic subnetting, understanding basic network, understanding the default gateway and the broadcast address and the routes and VLANs, if you understand these core concepts, they're going to position you to know a fair bit about building automation. Sure, there's more complexity to it, but it will get you started in the right direction. So I'm going to move back to my computer, see what questions we got. All right. So let's move over here, switch over that. Building systems. Nope. Okay. No other questions so far. All right. That makes my life easy because I have a hunger headache. I'm hungry. Let's see. Does anyone else have any other questions related to IP and networking? It's a pretty simple example, but this will kind of point you in the right direction as far as what you need to know in regards to basic IP networking. As always, like I tell you all every time we meet, we do have something that covers this. If you want to dive deeper into it, I will give you all a link to that. And you're more than welcome to go and look into this course. Can you use .01 to .16 on 2 switches? You can if they're on the same VLAN, but you can't have duplicates. So you can use a VLAN to have subnets stretch across multiple switches. That being said, for that subnet, you can't use that address twice. So each I/O device has an IP address, therefore a table must be established. Not every I/O device has an IP address, but if it's plugging into a switch, it typically will. It will typically be IP traffic, and in which case the address resolution protocol table, which will be automatically generated in a switch every 5 minutes as traffic goes out, because the switch will send out an ARP message to discover what devices are connected to it. And then it does keep alive to make sure those devices are still connected to it. Good questions. Let's see. Anything else? Nope. All right, we'll give you a minute or two to ask whatever else you got. And if you don't have any other questions, then I will go have my lunch. Where can I set my headphones? There we go. All right, cool. Not seeing any other questions. So next Monday, we are going to start diving into BACnet. We're going to look at BACnet objects. We're going to talk about devices, device properties, and we'll just take a general look at BACnet. As always, make sure you subscribe and leave a comment and hit the bell so that you get notified when we go and do these live streams. You can always leave questions after the fact. Thanks a ton, and I will see you all Monday night.